Today we will start from question number 46. So let's talk about question number 46. It is saying that question number 46. Consider the following properties for clays X and Y. Liquid limit of clay X is 42 and clay Y is 56. Plastic limit is 20 and clay Y is 34. Natural water content of clay X is 30, Y is 50. Which one of the clay X or Y experiences larger settlement under identical loads? If there is identical load on clay X deposits and clay Y deposits, then who will settle more? Then which one will settle more? This is the question. So for settlement, if settlement is delta H, then delta H by H is equal to nothing but delta A divided by 1 plus E naught, initial void ratio. And if you take uh, the coefficient of compression, then it can be written as Cc, coefficient of compression, log sigma 2 by sigma 1, and this is effective stress. Load is identical, divided this divided by 1 plus E naught. So settlement delta H is directly proportional to coefficient of compression. And you know that coefficient of compression Cc is 0.009 into WL minus 10 WL liquid limit minus 10. So as WL is more for higher WL, if WL is high, this implies that Cc will be high, coefficient of compression will be high, and this implies that delta H will be more. So for higher WL liquid limit, the settlement will be more. So in this case, liquid limit of Y is higher, therefore clay Y settle more as compared to clay Y. Sorry, clay X. Okay, clay Y settle more as compared to clay X. Okay, so this is the first one. And the second question in this is more plastic. Which one is more plastic? Okay, so to check more plastic, which soil is more plastic, uh, this is second. So we calculate IP. So IP of X is equal to liquid limit minus plastic limit, and this is 42. Liquid limit is 42 minus 20, so this is 22, and ip of Y is equal to liquid limit minus plastic limit, and this is liquid limit is 56 and plastic limit is 34, and this is also 22. So for both the soil, IP is same. So what to do in this case? Which clay is more plastic? It's very difficult to comment on plasticity. So we can take the help of uh, plasticity chart. A line, we can take the help of A line. So if we take the help of A line, so this is plasticity and this is water content. And if it is A line, this is A line. Okay. Above A line, clay exists, and below A line, that is silt or organic soil. Organic soil below A line. Okay. So we will decide the nature of clay. Even here, uh, uh, it is written that clay X and clay Y, but uh, I'm going to use the A line. So according to this, the formula for the equation of this A line IP is equal to 0.73 WL minus 20. So this value is 20. Okay. So from here, for IP in case of X, 0.73, and WL is 42 minus 20, and this result will be 42 minus 20. So 22 into WL minus 20, 42. Let me solve this. 22 multiplied by 0.73. See, this is 16 point. This is 16.06, and this value is, that is 22. So this is less than 22. So soil X lies above A line, that is, and it will be clay, and it will be clay. Similarly, IP of Y is equal to 0.73 into this is 56 minus 20. When we calculate this, 56 minus 20, 56 minus 20 multiplied by 0.73 is 26.28. This is 26.28, and this value is greater than 22. Therefore, soil Y lies below A line, and it will behave like behaves it will behaves like mm, silt and organic soil. So soil in X soil X lies above A line, and it will behave like clay. Okay. So clay behavior is more plastic as compared to silt and organic uh, soil behavior. So in this case, you can say that soil X, therefore the conclusion is soil X is more plastic, therefore 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 soil X is more plastic than soil Y. Okay, this is second. And third one is Third one is uh, softer inconsistency. So let me calculate consistency index. So IC is WL minus WN divided by WL minus W WP. Okay, so IC of X is WL is 42 minus 30 divided by 42 minus 20. So this is 42 minus 30. 42 minus 30 is 12 divided by 22 is equal to 12 divided by 22 is 0.54. 0.54. And uh, similarly consistency is 54. Similarly consistency of soil Y is equal to 56 minus 50. WL is 56, natural water content is 50 divided by 56 minus 34. WL is 56 and WP is 34. So this will 6 upon, this is 2 and 222. So this is 6 upon 22. 6 upon 22 is 0.27. 0.27. Therefore, IC of Y, consistency index of Y, is less than consistency index of soil X. Therefore, therefore soil soil Y soil Y is softer in consistency softer in consistency. So according to this mm, explanation, the answer will be clay Y settles more. So first one is Y, comma. In this case, therefore, soil X is more plastic. Soil X is more plastic. So X and then soil, therefore soil Y is softer. Soil Y is softer and Y. So Y, X and Y. The option number C will be the correct answer. Okay. So this is the solution of question number 46. Very important. Okay. Now next question is question number 47. Next question is question number 47. Question number 47. What is saying that for a sandy soil with uh, soil grains spherical in shape and uniform in size, what is the theoretical word ratio? So theoretical word ratio, the maximum theoretical word ratio is 0.91 and the minimum word ratio is 0.35 is 0.35. So Emax 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 is 0.91 and it is in the case of cubical packing. It occurs in it occurs in cubical packing. Okay. And E minimum, the value of E minimum is 0.35, and it it occurs in rhombohedral or pyramidal packing. Okay, rombo, rhombohedral or pyramidal, pyramidal packing. Okay, so um, the answer of this question will be 0.91. Okay, so spherical in shape and uniform in size. What is the theoretical wide ratio is zero point 0.9. Okay, this is question number 47. Now question number 48. Question number 48. A soil has liquid limit 35, plastic limit 20, shrinkage limit 10, and natural moisture contains 25. What will be its liquidity index, plasticity index, and shrinkage index? So liquidity index. Oh, first I'm going to determine consistency index, and you know that the sum of consistency index and liquidity index is 1. Okay, so IC is what? 30. IC is WL minus WN divided by WL minus WP. So WL is liquid limit is 35 minus 25 divided by 35 minus plastic limit is 20. So this is 10 upon 15 is 2 by 3, 0.67. Therefore, IL will be 1 minus IC is equal to 1 minus 0.67 is nothing 0.33. Okay, so 0.33, 0.33. IL, liquidity plasticity index. IP is equal to WL minus WP. So WL is 35 minus 20 is equal to 15. So this. And the next is shrinkage index. So shrinkage index is WP minus WS is equal to WP is 20 minus WS is 10. So this is 10. This is 10. So option B is the correct answer. 48. Option B is the correct answer. Okay. Now question number 49. Now question number 49. Question number 49. In the wet soil mass, air occupies 1/6 of its volume and water occupies 1/3 of its volume. The wide ratio of soil is the same question 49. Same question as question number 4. This is same question as question number 4. And question number 4 is asked in IES 1995, and this question is asked in IES to in IES 2010. Okay, so The question is repeating. Concept repeats. 85 to 90% questions exactly same if we compare with the concepts. Okay. And some question directly comes from previous year questions. So it is very important to solve all previous year questions. Okay. So the answer of this question, you can go and see solution of question number 4. Okay. Now question number 40, question number 50. Question number 50. A specimen of clay silt contains 70% silt size particles. Its liquid limit is size of silty particles. Specimen clay silt contains clay silt. Clay silt contains 70% silt size particle. There therefore it will contain 30% clay clay particles that is size less than 2 micron. So percentage of particle particle size less than 2 micron, that is clay, is equal to 30%. Its liquid limit is 40, and and plastic limit and plastic limit is 20. In liquid limit test at moisture content of 30, WN natural moisture content 30, required number of blows 50, number of blows requires is equal to 50. Its plasticity index, activity and consistency. So plasticity index IP, let me change the color of pen. So first is its plasticity index IP is equal to WL minus WP. So 40 minus 20 is 20. So this is 20, this is 20, this is also 20. Okay. Second is activity. So AC is IP by percentage finer than 2 micron. So this is IP is 20 and this is 30. So 0.67. So 0.67 is this one, 0.67. And third is consistency index. So IC is equal to WL minus WN by WL minus WP. So WL is liquid limit is 40 minus 30 divided by 40 minus 20. So 10 by 20 is 0.5. 0.5. Option number A will be the correct answer. 50, option number A. Now the next question is Question number 51. Question number 51. Question 51. Consider the following statements. At shrinkage limit, the soil remains fully saturated. At shrinkage limit, the soil remains fully saturated. Yes, statement 1 is correct one. No doubt. This is correct statement. The shear strength of all soil at liquid limit is same. Yes, this statement is also correct. And it is 2.7 kilonewton per meter square. The shear strength of all soil at plastic limit is same. No, at plastic limit, um, the shear strength will be different for different soil. So this statement is wrong. So statement 1 and 2 is correct. So option number B is correct answer. Okay. Now we will see question number 52. Question number 52. This is question number 52. Question number 52. I'm trying to enlarge the size. This question number 52. Consider the following statements. Peat and muck are organic soil. Yes, peat and muck is organic soil. What is the difference between peat and muck? Peat and muck. Peat is fibrous organic soil, that is less decomposed version of organic soil. So peat is a less decomposed version, that is fibrous organic soil, and and it is less decomposed version less decomposed version of of organic organic soil. Okay. And muck is highly decomposed organic soil. Highly decomposed highly decomposed organic soil. Okay. So peat is an inorganic soil, whereas muck, this is wrong statement. Peat and muck both are organic soil, and the only difference is it is less decomposed. Peat is less decomposed, and muck is highly decomposed organic soil. Both are organic soil. Okay. Second statement is wrong. Third, indurated clay is a type of clay which does not soften under prolonged wetting. Yes, this statement is correct. Indurated clay is a type of clay which has been hardened due to heat and pressure. So it does not soften under prolonged wetting. Okay. So what is indurated clay? Indurated clay is a type of clay which has been which has been hardened which has been hardened due to due to heat and pressure heat and pressure, so it does not soften, so it does not soften under under prolonged prolonged waiting. Okay, intermediate clay is a type of clay which does not soften under prolonged wetting. Okay, because it is hardened due to heat and pressure. Okay, question 1 and 3 is correct. So option number D is correct option. Okay, now question number 53. I'm trying to uh, enlarge so you can see it easily. Okay, so question number 53. What would be the volume of water stored in saturated column with porosity 0.35 with a cross-section area of 1 and depth? So this is the cross-section area. Cross-section area is 1 meter square and depth is what? Depth, depth is 3 meter. So volume is what? So therefore volume is equal to 1 into 3. This is equal to 3 meter cube. And what is porosity? Porosity is volume of void upon total volume. So volume of voids will be porosity into total volume. So porosity is 0.35 and total volume is 3. So this is 5, 10. So 1 point. This is the volume of void. Okay. So what would be the volume of water stored in saturated column? So in saturated column, the volume of water is stored will exactly equal to volume of voids, and it is 1.05 meter cube. So answer will be this. Okay, so option number C is the correct answer. 53. Now we'll go to 54. Question number 54. 54. The natural water content of soil sample was found to be 40%. So WN natural water content is 40%. A specific gravity is gravity is 2.7 and void ratio is 1.2. Then the degree of saturation of the soil will be S is equal to what? So use a well-known formula, SE is equal to Z into W. So S is equal to Z into W by E. So G is 2.7, W is 0.4 divided by E is 1.2. When you calculate this, you will get you will get 0.9. Okay, this is 0.9. This is 90%. Okay, so option number D, 54. Okay. Now we will solve question number 55. Question number 55. Question number 55. The porosity of soil sample having its void ratio equal to unity. So porosity of soil sample having its void ratio equal to unity. So E is equal to 1. So porosity is equal to E divided by 1 plus E. This 1 divided by 1 plus 1 is equal to 1 by 2 is 50%. Okay. So B, 55, B. Question number 56. Question number 56. What is this? Question number 56. Consider consider the following statement. Relative density is a meaningful parameter for all types of soil. Relative density is meaningful parameter for all types of soil. No, this is wrong statement. This is wrong statement. Um, this is wrong statement because relative density is not a meaningful parameter uh, in case of clay. It is a meaningful parameter in case of sands. So in this statement, relative density is meaningful parameter for all types of soil. No, this is wrong statement. This only meaningful is relative density. Relative density is meaningful is a meaningful parameter only in case of sandy soil. Okay, that is for cohesionless. That is for cohesionless. That is for cohesionless soil. Okay. Now option statement 2 is relative density is a meaningful parameter only for cohesion soil. This is not cohesion soil. This must be in place of cohesion. That must be cohesionless. Okay. This is cohesionless. So this statement is correct. If it is cohesive soil, then this is also incorrect. So if 2 is incorrect and 1 is incorrect, then none option is matching. None of the option will match. So cohesion here, um, this is a typing mistake, I think. So cohesion in place of cohesion, that is cohesionless soil. So relative density is a meaningful parameter only for cohesionless soil. This is correct. Okay. So statement 1 is false. So this is false, this is false, this is false. Statement 2 is correct. So let's see the statement 3. Relative density is a better indicator for the denseness of an in situ granular soil deposit in situ granular soil deposit than the wide ratio. Yes, this statement is correct. So option number C is the correct answer. Okay. So this is all for today. Um, remaining question we will discuss in next video. Sure. Thank you, everyone. Okay, everyone.